Okay, let's talk about the ambiguous case. The ambiguous case comes into play. There are three separate cases with the types of triangles that we can solve here, and we'll talk about it in just a sec. It comes into play when we talk about the side-side angle triangle. So we know that that law of sines won't work if we have a side-side-side and a side-angle-side. It will work if we've got angle, angle, side, and also side, side, angle. Sometimes written as angle, side, side. Don't tell your parents. All right, so watch what happens here. Let me show you what can happen. If I know an angle and two sides, so in other words, I'm not in this situation where I know the included angle, but I know an angle, its opposite side, and one other side. Watch what can happen. Let's say, for example, I'm going to make up some stuff. So let's say that I have angle A equals 40 degrees. And then let's say that side B is 10. Whoops, B equals, what the heck's going on? I put my comma in the wrong place. Ding dong. Side B equals 10, you know it's my favorite. And then let's say that side A equals 1. Now think about what's going to happen there. The very first thing that I always do, and there's absolutely no rule that says that you have to do it this way, okay? The first thing that I do is I draw a horizontal line, all right? And then I make a 40-degree angle. So, you know, I'm decent at making 40-degree angles. So I'm going to make this a 40-degree angle of length. Oh, I hate it when I do that. Sorry, guys. Sitting over here stammering around. I make a 40-degree angle. And I'm going to make this of length 10. And this is going to be my 40-degree angle. Now, think about this. This is actually going to end up being my side C. But I'm going to leave it dotted because I don't know what it's doing yet. Okay. Now, if I make a side length of A equals 1, what's got to happen? That's 1, right? More or less, badly drawn. It's like it's dangling here. In other words, for this angle to truly be 40 degrees, this is going to sit here and dangle, and it's not going to be able to reach all the way down. It can't even make a right triangle, let alone, you know, some triangle with acute angles or an obtuse angle. Now, let's see how this plays out angle-wise. So let's see, this is actually, okay, so this is B equals 10, which means that if I'm trying to solve for some mystery angle, which is right here, I'm going to call that angle B. Well, watch what happens. Let's actually do it on our calculators so we see that when our calculators gives us this feedback that something ain't right. I know that sine of B is to 10, side B, as sine of 40 is to 1, right? Everybody agrees with that? So I know that sine of B is equal to 10 sine of 40 degrees. So B is equal to the inverse sine of 10 sine 40 degrees, correct? Now, let's go to our calculators real quick. Now, your spidey sense is probably already tingling here a bit because 10 sine 40, ooh, that smells like it's going to be pretty big, but let's prove it. Let's go over here, and I'm going to go just to look first, okay? Watch. If I just go 10 sine of 40 degrees, let's get our brains wrapped out. Check our mode. Make sure we're in degree mode. Yes, we are. Thank goodness. I keep doing that. I got to come over here. Oh, I guess I could just hit enter, right? What is 10 sine 40? It's 6.42, which tells me that this is actually equal to the inverse sine of 6.428, if I want to be more specific. Wait a sec. That's telling me that the sine of some angle is equal to 6.428. Wait, sine's range is from -1 to 1. This ain't going to work. This doesn't exist. There are no solutions to that. And that plays out on my calculator. If I hit second sine of second answer, which is down here, right? Watch what happens. Bah! Error domain. It yells at us, which is great. So I'm just going to hit quit. And look at that. It's like, no, wrong. So what does this mean? This means there are no such triangles. There are no triangles that have an angle of 40 degrees, one side of 10, and an opposite side, opposite the 40-degree angle of side 1. Okay, so that's one of the three ambiguous cases, or one of the three side-side angle cases. All right, let's look at this one. So we're still doing, remember, we're going to do side-side angle. Only this time I'm going to go angle A equals 40 degrees. Let's see, side B is equal to 10, and side A is equal to 15. Okay, let's see how to build this. So what I always do, I speak the King's English, so I think from left to right. So I put my 40-degree angle over here, right? I'm going to make a side length of 10, and then I'm going to make another side length of 15. Well, where does that 15 go? There's no way that I can crank that angle of, or that side length of 15, because watch what happens if I try to. If I try to do 15, I know that 15 is longer than 10, right? So if I try to crank that guy back here, what's going to happen? It's going to open up this angle, and it's going to make it bigger than 40. Well, that doesn't work. There's no way that that can happen, right? So I have no choice. If the side opposite the given angle is longer than the other side, that's actually a really good situation, because all I do then, let's see, where am I? Let's do that, is I have no choice but to send it way out here. All right? Well, that's cool. Let's see, 15, and there we go. All right, now let's label our stuff. Just like before, this is B equals, this is A equals, this is angle A, and I'm going to solve for angle B, right? Sine, we're going to do these quick, okay? Sine B is to 10 as sine 40. 40 is to 15. I know that B is equal to the inverse sine of 2/3, sine 40, right? 2/3 sine 40. I might even have that in my calculator. So this is approximately equal to, I think I do, let's see, second, entry, second, oh crud, never mind, quit. Well, I'm going to have to do it by hand, bummer, quit, go away. Okay, so inverse sine of 2/3 divided by 3. See how I like to use nice clean numbers? Not on tests. Sine of 40. And let's see if the number that we get makes sense. 25 degrees. So this is approximately 25.374 degrees. So that's this guy. This is going to be 25.374 degrees. Sweet. Now let's double check to make sure. 10 is smaller than 15, so angle B, that's a 2 by the way, angle B had better be smaller than angle A. Yeah, and sure enough it is. And notice, I avoided the obtuse angle because arcsine won't spit out obtuse angles. So I can't wave my hands strongly enough. You cannot use obtuse angle or law of sines to solve for obtuse angles. You have to use other tricks. Well, what other tricks? Easy. I'm just going to use the fact that all three angles add up to 180. Okay, so this is side or angle C, and this is side C. So I got a free piece of information. I know that angle C is equal to 180 minus 40 degrees plus 25.374 degrees, right? And let's see if we can do, so this is 180 minus what? 65.374 degrees. How good am I? Well, let's check. So what's that going to be? 114.626. 114.626. Let's check. Just see how good I am. 180 minus 65. It's stupid to make a. I mean, I enjoy trying to do these things in my head just to keep my old breath. Look at that! Woohoo! Ripley rules, Ripley rules. But it's stupid to lose points for not using your calculator to check your work. It's good practice, though, to get your brain kind of cranking. Okay, once I have the obtuse angle, I'm golden. I just use law of sines again. Notice I solve for C. I'm not going to write it in up here because I'm getting too crammed up there. Now I need little c. So I'm not afraid. Sine of 114.626 divided by little c is equal to, now which angle am I going to use? Think. Which angle do I want to use? Do I want to use 25.374 degrees or do I want to use 40 degrees? We're already rounding here. So I want to use the sine of 40 degrees is to 15. You dig it? You know why? because that's not rounded. If I round on top of rounding on top of rounding, I run into trouble very quickly. I'm going to do a puff of algebra really quick here, and I end up with C equals 15 sine of 114.626 divided by sine of 40 degrees, and I'm off to the races. So let's see, I got to go 15. That's just Algebra 1 stuff, right? Hopefully I didn't screw it up. I love it when I say stuff like that and then I screw it up. Sine of 1, ooh, look at this, second. I'm going to steal second answer. And then I don't have to round. That's awesome, right? And then I'm going to divide by sine of 40. Sine of 40 degrees. Whoa. Oh, wow. Okay, I just had a little lag there. That frightened me. And entrée. And let's see what we get. C is approximately equal to 21.213. So this guy is 21.213. Now, if you're doing this on a test or a quiz, I want to make sure that you highlight what you had to solve for. In other words, if it were me, I would list that angle B is approximately equal to 25.374 degrees, thus not making me hunt, which is a good thing. Angle C is approximately equal to 114.626, and side C is approximately equal to 21.213. That makes my life easier because I can check these answers, then I can check your work, and I check it off, and life gets really, really good. Remember, happy grader equals happy student. Okay, so we've got the case where we dangled and we had no triangles. Then we have this case where this opposite side, the side opposite A, is longer than that side that's given, in which case I have one triangle. Now, you may be going, Ridley, how is it possible to have more than one triangle?